I'd like to introduce Tony Salas. Tony, it's all yours.
Thank you, Mr. David. Good morning, good afternoon, everybody. Yes, it's a lovely day here in Las Vegas. Our subject of today is going to be common rail, light duty common rail diagnosis. Uh, as you know, some of you have been in my classes and or other webinars or other training through the years and probably seen me talk extensively about common rail. So in this case, when I was putting together this presentation of various different other presentations, making one out of it, I stopped to think about what is the common things that I get phone calls about. And it's remarkable how many technicians out there that I talk to or they ask for help. And they always ask for, what am I doing wrong? I'm not getting fuel rail pressure. What's going on with the system? So there's many aspects to the common rail diagnosis, but please note, being a small little shop that I now am, I'm just a one-man show now. I got two part-timers here that work part-time with me, but when we actually do diagnosis or even when I go on the road, I just came back from different locations. And in this case, what I'm trying to say is we had to come up with ways of how we diagnose on vehicle diagnosis. Some of you that have the nice feature of having some type of bench tester in your shop, well, God bless you. That's a good thing. Take the injectors off, test the injectors. That's really good. But my whole training has been evolved on doing it on vehicle. And sometimes it's been challenging, but there's always that one truck that led us to, further diagnose with more efficiency the later models or the other models. So, but before we get started here with Common Rail, obviously I'm not just going to dedicate just to the injector itself, but to the systems and subsystems that affect Common Rail itself. But in this case, as we've been saying over and over again through the years, and those of you that do rebuilding or know about those that do rebuilding or servicing of those common rail parts, whether it being injection pumps, whether it being injectors themselves, the number one enemy of consistently of common rail has been what? Contamination. Contamination has always been a problem. So therefore, cleanliness of the systems, we cannot stress enough about that. Maintenance of that fuel system, especially that fuel isn't the quality is not consistent. So when I talk to new Jeep owners, for example, here that buy the diesels, I've been using my Jeep Club here in Vegas as an example. And in this case, I talk to them about fuel, diesel fuel, is the fact that it's not consistent, meaning that we have tested fuels around in our area here, and we see inconsistency sometimes with fuel. So it is amazing how guys will sell or shops will sell a whole injection pump, injectors, rails, and so on, but yet not test the fuel quality. So something to keep in mind is, yeah, you got to look at the fuel quality that the customer is using. Perhaps need to make a note of it because that can cause premature failure of the common rail system. And then we talked about lubricity. There's always been talking about lubricity, the ultra low sulfur fuel. In this case, we see the 15 parts per million as the maximum allowable sulfur content because in our trade, we tend to reference sulfur as the lubricant factor. And the thing is, there's no minimum. Okay, so therefore, if you compare European and Canadian diesel fuel, they've always have had a lubrication standard. So again, when we see the issues going on with the lubricity affecting the common rail system, whether it being the pump or a certain style of injectors, that's always been an issue. So I guess we live in a day and age where we need to ask ourselves this question is, should we be using or selling more than ever some type of additive, whether it be a lubricant, a cetane improver, or a cleaner? So in this case, yeah, we have to look at that because that can affect the common rail injection life. So now I'll tell you some stories later on. You could take them for what it's worth. And you guys, I'm sure, have your own stories about your additives. But again, should we be pushing some type of additive because of the inconsistencies of fuel? When I get phone calls, because obviously I know pretty much everybody all across the United States, and it's amazing how one specific area will call me. It's been a while though, but they'll call me and they'll say, "Hey, Tony, what's going on with these pumps or what's going on with a certain injector or whatever?" And it turns out that it seems like it's a regional problem where fuel can be the problem. So I guess what I'm trying to say is, you take a look at your fuel quality. We have a specific gravity tester here where we test the specific gravity of the fuel. That's a good amateur test, but it's something so we can have an idea of is there extensive water content in the fuel itself. So you come up with your own ways. I mean, if you want some more information about that, let me know. But very important to understand that fuel and contamination is an issue with the common rail system. So But when we look at the common rail systems that we'll be discussing here, obviously I only got so much time to discuss a whole bunch of systems, but we'll try to go through them. Obviously, the first common rail that I was born with is the LB7. I'm not going to lie to you. It's always been GM Duramax. That was my first. And in this case, from there, we took the information from LB7 and carried on some of the test procedures, some of the things we can do. And in this case, we saw the common rail introduced in 03 Dodge Ram on the 5.9. And then for Ford, we saw the 6.4 use a Siemens common rail. So Ford did not come on board with common rail, if you really think about it, for trivia purposes, not till 07 with the Siemens common rail. And that only lasted a few years, 3 years. But then in 2011, Ford went with Bosch piezo common rail injection, but it was a piezo, unlike what we saw with the Duramax from LB7 all the way to LMM. We saw them being using a ball and seat injector. Then they went to piezo in 2011. That's what we see there with the LML Duramax. And obviously Duramax, as we discussed on the previous Lucas sponsored webinar last month, we talked about the L5P Denso common rail. Excuse me, a few months ago. But in this case, we saw the L5P Denso common rail. So a lot of changes, but when I look at a common rail system, it all relatively is the same to me. What I mean by that is there has got to be some kind of fuel supply, meaning there's the fuel tank. We got to get fuel to the common rail injection pump, which pressurizes the fuel, moves that pressurized fuel towards the rail, and finally goes to the injector itself. So the final destination is to be injected into the cylinder itself. So therefore, what I'm trying to say is there's got to be some commonality that I try to use. Sometimes I get curved balls here and there in terms that, oops, this could be this or this could be this. So again, it isn't always that simple. So when we first started, again, with the LB7, again, I'm not going to be staying basic on the LB7 because I'm sure a lot of you have diagnosed the LB7, but it kind of set the precedence of future common rail systems that we see now for 2022 and now future 2023 models coming out. So in this case, we saw the fuel tank, and in this case, that fuel tank played a key role here in supplying the fuel, but again, the fuel quality. And the question begs, if this truck has got a lot of age, let's say it's a 2001, right? It's a common rail old LB7. The question begs is that, should we be dropping that tank and wondering how much water accumulation and debris might be in that tank? And through the years, by testing different fuel systems, it isn't surprising that maybe somebody went and experimented with biodiesel, and we see a whole bunch of glycerin at the bottom of the tank. That can also happen. But again, the tank is the fuel supply we got to check. In the early years with the 6.7s, we saw some issues with water intrusion going to the tank. So again, we saw water content there. So the frustration as technician is to sell the customer, do I need to sell them the labor to inspect what's going on in the tank? So one of the things you're going to see about the LB7, I got mine sitting right here, is, we got our gauge, and in this case, we've been using this gauge here. And this gauge has pretty much been used extensively for testing those Duramax all the way up to, the LMLs. So in this case, we're measuring the total suction. But one of the things that we're seeing, I'll show you examples of worksheets we used in the past in our training where, you're going to go ahead and measure the suction. How well is that suction going there? But if the suction is too high, the service instructions tell you to go ahead and replace the fuel filter. But we're like, okay, if the filter got that dirty and I don't know when that filter was last changed, maybe it's a good idea to have that customer come back in a week or two and let's put a gauge again and let's see if that suction's going up again. Because if that filter's readily getting contaminated already, that means that we definitely have some debris in the tank. And those of you that work with, the agriculture community, you probably know that it's amazing how even these tanks can get full of hay. So again, the fuel tank is very important. So as I move around here and I look at the common rail system here, we see that we have our injection pump. And like we saw with the LB7, the CP3 pump was the injection pump at that time, used extensively through the years. And therefore, at that point, we saw the fuel going towards a junction block where we saw the pressure limiting valve and the fuel rail pressure sensor. But as time went along, we saw a change going on to that. But regardless, we saw that the pressure was distributed to each common rail itself. So the purpose of the common rail was, it's in essence to provide the same amount of equal volume and pressure going to each individual injector. But we know that not all the injectors are not all working at the same time. It's one at a time following a firing order. So therefore, yeah, we did a lot of basics here. So therefore, bear with me. I know it's kind of basic what we're talking about, but we tend to misunderstand, some of us that are amateurs, especially not amateurs, but novice technicians that are not fully experienced, is that we have a suction side, we have a high pressure side, and we have a return. So the first thing we struggled back in the day was, what happens when the truck comes in with an adequate rail pressure? There's not enough rail pressure. And in this case, it wasn't always the pump. And it still happens to the day, because I talk to rebuilders from time to time, and they see quite a number of injection pumps. And in this case, the pumps are fine, they're just dirty or contaminated. So the question begs, when the truck comes in and it's got low rail pressure, a amateur, or shall I say once again, an apprentice style technician, or somebody who doesn't have experience with common rail, tends to want to replace the pump. But the pump does not fail as much as we think it does, depending which model we're talking about. But in this case, it does not build any rail pressure, but they tend to forget that it must be built against the injector. So you're gonna build rail pressure, you got to push it against something. Now, when we look at literature from the Power Stroke 6.4 with the Siemens Common Rail, they were talking about disconnecting a line to see if there was contamination. So again, goes back to that contamination not being just metal, but also other debris that might be in the common rail system. But once again, sticking to the LB7, we're sucking fuel out of the tank. So therefore, from the pump to the tank, it was all a suction. So if we compare that with a Common Rail 5.9 on a Graham Cummins, we still use the same injection pump. And guess what? It also had the same transfer pump. So on the back of this injection pump, there was a transfer pump that actually pulled the fuel from the tank. So if we look at common rails, like on some commercial vehicles, you're going to see that the truck will still run even if the lift pump on that application doesn't work. So it's able to pull fuel through the actual pump itself and bring it into the common rail itself. It won't build adequate rail pressure, but it'll still run. But it's kind of funny how those will work. But regardless, Duramax was known for the longest time to use suction all the way up to the LMLs. But when the L5P came out with the Denso common rail system, they added a lift pump. So therefore, Duramax was the king of suction, I guess you can say. So we were using this gauge to actually measure suction. But since we're sucking fuel, one of the key elements that I still see from time to time on Duramax applications is the fact that the fuel cap is rather unique. And in this case, you'll notice that this fuel cap, is actually venting the tank at 1 inch of vacuum. So therefore, if we're pulling fuel, it is possible that we create a low pressure in the tank. So what can happen is that it collapses. So from time to time, I'll look underneath an older Duramax and I will see that, the creases of that tank, if this, this composite tank, you're going to see that they tend to be moist. And that's because the tank has been contracting, expanding, contracting, expanding. But when it contracts, it's because it's drawing so much suction that in turn, it actually builds a vacuum in the tank. So the cap is supposed to be specified to open at 1 inch from GM itself. So the problem is when you put a locking cap on, many of them don't meet that specification. Then on the opposite end of the spectrum, we see a return coming into the tank. So in turn, we build the pressure into the tank, which again can actually go up to 2 psi. So I guess what I'm trying to say is make sure we have the correct cap on these Duramax applications. So very important to understand. But then as we move along here, we saw that the weakness of a Duramax also, again, from LB7 all the way pretty much to the LMLs, was this hand primer pump. And I've been teaching for years that, in the past, in the early years, we were talking about putting a clear hose, because even GM and their service procedures wanted you to put on these lines a clear hose to see if there was bubbles, if it were aerating. But one of the tests that I found out is that, well, most of the time, not all the time, but most of the time we see that this hand primer pump will actually kind of be aerating the system in a loose prime. It'll be one of those situation, you park the truck after some driving time, and then you'll come back 10-15 minutes later, you try to start up the truck and it won't start, and you have to prime it to get the truck running. So that means we're losing prime there. So in many cases, what we do is we actually put a vacuum on this outlet tube. So here's the inlet coming in, then you got your outlet. And what we do simply is we actually get our vacuum pump adapter with the little container so we don't suck fuel into the vacuum pump. But what we do is we put it in a vacuum and see if it holds vacuum. And if it does not hold vacuum, then probably, or most likely, the issue is the primer pump. And like I mentioned before in previous webinars, I no longer rebuild these anymore. It is cheaper to buy the whole assembly. Many vendors sell it, where it even comes with the filter, the water and fuel sensor, and the plunger pump. So a whole new unit. So I don't rebuild them anymore. Even though they still sell the rebuild kits from many different vendors, I'll just understand that that is a hot spot when it comes to losing prime. Now, do me a favor though, in any Duramax application, especially from the LB7 to the LMLs, make sure you check these hoses. These hoses get old in time, and it's time to call your local GM supplier or whoever sells these hoses and actually go replace these hoses if necessary, because they can also become brittle and actually start to come apart on the inside. So definitely keep an eye on those hoses. Now, as we see on later model Duramax, you're going to see that they're using a vacuum switch. So again, we're actually monitoring that suction. So too much suction again will mean that we most likely have a restriction. Number one tends to be the fuel filter, but it could be other components, but primarily it could be the actual filter itself. Now, we could have a restriction on the pickup inside the fuel tank, but in this case, like I said, this tends to be the issue with the fuel filters. Now, I know there's a lot of aftermarket fuel filters being sold, so since I'm not a GM person, I can say, hey, there's the CAT adapter, there's the dual filter adapters that you can get from FAST and other manufacturers, and AirDog. All I'm saying is, yeah, this I believe and I feel that this vehicle is under filter. When you look at the surface area to do water separation and filtration, yeah, we're asking a lot of this out of the stock filter from Raycor. So therefore, it's a good idea to actually put a supplement filter if possible. Now, I'm not going to lie to you, since we were talking about suction, and when it comes to the LMLs, I will be honest, if I have a catastrophic CP4 failure on those, we will go ahead and add an aftermarket lip pump. So I have my favorite, but in this case, they do sell them that are bolt-on, ready to install just the pump. I don't need to install a big assembly, which is a big high-dollar filter aftermarket assembly, but it'll suffice with a good pump itself that could be in the neighborhood of $400 to $500. It's a lot cheaper than having to buy those big units that can exceed over $1,000. So if you're looking to economize, but again, I will not. That's my opinion. So I hope you understand, but I do not put a LML back together with just suction alone. I will put an aftermarket lip pump due to the fact that that CP4 needs a consistent fuel lift pump volume and no air in the system. Now, from time to time, very rarely it happens, but please note, for Duramax applications and 5.9 Cummins applications, there was never no timing or phasing of this injection pump. And it makes sense because all the pump does is suck and pump. It's not time to trigger a mechanical injector like the old days. But in this case, please note, from time to time, maybe once a year, I get a phone call, but I'll mention it anyways, where a technician will install an injection pump, especially these CP3s. And once he gets it started, everything runs great. It actually accelerates fine, but you get an off idle. As soon as you accelerate, you get an off idle knock. And it's a diesel knock, and it's something that have to do with harmonics. And in this case, what is the fix? You think there's something wrong, but there's nothing wrong. It's just audible harmonics that we get. So on a Duramax, it sucks because you literally have to get back into the valley of the injection pump, take the injection pump up and out, and rotate it at least 30 degrees and put it back in. That should take care of that knocking sound. So therefore, be aware of that. It could happen. I get them I haven't had one in a while, but I won't lie to you, but it has been known to happen. So it can happen on a 5.9, but on a 5.9 Cummins, it's a lot easier because it's a lot easier to get the injection pump. So therefore, it's a lot better, a lot easier. So word to the wise. So when we look at it, I was looking at my old worksheets that we used to use both at GM and in our classes. There was good procedures that were outlined there, and we told the guys in the classes to go ahead and take this and apply it when you do diagnosis. In other words, have a procedure. So, you're supposed to hook up your gauge on these Duramax applications, and what you do is you go ahead, like we say there, you're going to pump it up to, again, 10 PSI and watch the rate of decay. In other words, you're pumping it up and you watch this gauge go up to, again, 10 inches, and then you watch the rate of decay on the gauge. So if it immediately drops, then therefore that was indicative that you probably had A, an external leak, or B, you have a bad cascade valve on the CP3 injection pump, which I'll get into here in a bit. But in this case, you were actually doing some certain tests. So again, you were going ahead and measuring the suction at idle. Should not have been no more than 4 or less. It should be 4 or less, excuse me. And if it was 5, the directions told you to replace the fuel filter. But again, we're supposed to do a test. But again, you're supposed to prime the system up to 10 psi, like I just showed you with the gauge I just have right now, and watch the rate of decay. This is a GM test, so you're watching the rate of decay to see if you have a leaky cascade valve. So if it leaked, that means the cascade valve was leaking. So, but you're probably saying to yourself, hey, Tony, the same injection pump is used on the 5.9 Cummins and 6.7s, right? Yeah, they have cascade valves. So how do you test that? Well, you do a return test on the injection pump, which I'll show you some numbers here in a bit. But once again, you're going ahead and measuring the suction at idle, and you're supposed to see 4 or less, right? Well, what about under load? That a lot of guys I talk to don't do this. You're supposed to put that gauge, and that's why it comes with a big old hose, big old hose here, as you can see there. So in this case, it's because I run it underneath the hood, and sometimes I'll just clip the hood on and hook it up to a windshield wiper or hang it off the side mirror there. And what I'm going to do is I'm going to do a loaded test. So like it says on the bottom of this slide, you want to do a loaded suction test to see what is the suction under load, because you can have issues there. Maybe it'll have 3 inches at idle, which passes, but what about under load? That's where you get that intermittent low rail pressure code set, especially under a load. Hell, we had one customer that drove us crazy that the only way we can duplicate his problem was to literally take it on the road up here towards the mountains, not about a good half hour, 45 minutes from here, and get on a nice 6% grade to finally duplicate his complaint, because there was no 6% grade here around close by to the shop. So therefore, what I'm trying to say is test her under load, but if you can put it under some kind of grade, that'd be even better. But in this case, is 10 inches is the spec from General Motors, but I have found rail pressure dropping at 8 inches. So you can use the Tony spec if you so choose, but in this case, 10 inches is what you want to do. So to recap one more time, you turn the truck on, you watch it at idle, 4 inches or less. You put it under a load, you want to see no more than 10 inches according to GM, or like I said, 8 inches. And if you do have a lot of vacuum under a load, yes, it could be the fuel filter, but if you've done the fuel filter, then the problem is probably in the tank at the pickup. Top kit Kodiaks, those early model top kit Kodiaks were notorious for that, where you pull the pretty much the pickup, and they weren't using a pickup sock, they were using a plastic pickup container with holes in it, and we literally had to drill holes on that plastic pickup because it was actually from the factory restrictive at that time. So, and I'm sure there's still out there quite a few of them that even have trash on them that are out there. So, but then on all these Duramaxes, all the way to LML, you're supposed to do a total suction test. So, on this LB7, they were telling you, but you can disconnect the, you can just leave the key off and run the starter if you want to do that. In other words, keep the key off, get to the starter relay right there in the engine compartment, and you can use one of those relays with the button on it. And what I do is I will crank the engine with the key off, and what I'm trying to do is do a total suction test. And what I'm literally doing is I'm pinching the line that goes between the outlet of the fuel filter and the injection pump. There's a line right there on the outlet line. I'm going to pinch it with some crimp pliers, and what I'm going to do is see what the total suction is, because I'm putting a major restriction with the crimp pliers, and at that point, I'm measuring the total suction, which should be minimum 15 inches. Some people say 10 inches. No, I get 15 inches. That's what you want to see. So therefore, that'll tell you the total suction of that primer pump that sits behind the injection pump. So therefore, that's what step number 7 is saying, is go ahead and restrict that line and crank the engine over and see what you get. So again, total suction test is what you want to do there. So once again, we started off at idle, crank the engine, you start up the truck if your truck has a drivability problem, that is, or a rail pressure code. And what you're going to do is you're going to measure again the suction, again, 4 or less. Then you go ahead and do a loaded test, again, 8 inches or 10 inches, whatever you want. And then you got your total suction test, where you're going to go ahead and restrict the line on the outlet of the filter and see the total suction. How well does it suck? So this will be a crank key off situation that you're going to do. And the last one that I almost forgot to mention was we started off with priming the system up to 10 psi and see if it drops slowly. If it drops fast, that means we got a cascade valve leaking. So that truck that I just told you about that we had to take up to 8% grade, I screwed up. I did not do that 10 PSI test where I was supposed to watch the rate of decay, because what was wrong with that system, why it was setting a low rail pressure under load, was a leaky cascade valve. There was excess return coming out of that injection pump. So that was it. So remember, there's got to be something that lubricates these CP3s, whether it being NA, LB7 Duramax, LLY, LMM, or even a Cummins 5.9 and some 6.7s. So therefore, the cascade valve maintains pretty much, as you can see here on this old slide, you can see that there's got to be loop fuel there, and that loop fuel is got to be maintained by the cascade valve. So therefore, that controls that flow. So here you can see an early model CP3 pump, and there you can see the cascade valve. Unfortunately, on a Duramax application, it is not easy to guess to. It is faced towards the passenger's head. So literally, if that's your issue, you're better off just replacing the injection pump. But on a 5.9 or 6.7 Cummins, yes, I can get access to them and I can actually replace them. So I am guilty of returning some cores without a cascade valve, because I'll steal them off of some normal good ones on some cores that I return. So, but they do sell them though. The cascade valves are available by themselves. So as we move along with Duramax, because we still got more common rails to talk about, we got time here, don't worry. But in this case, you'll see the LML and later Duramaxes from 06 and later. We saw that they got rid of the FICM, no more fuel injection control module. And we saw that there's no more junction blocks. So therefore, same system for the most part. But in this case, we see the injection pump sending fuel to one rail, and one rail feeds the second rail. Now, I got to be honest, for a lot of years in the early years, and when I'm talking about back in 2010 or earlier, we used to do injectors and stuff, and we never replaced the rails. But after some time, back in the day, we started sticking our boroscope into the rails, and it was just astonishing how much rust and crud there'd be inside the rail. So we inspect the rails, but for the most part nowadays, on most applications, we actually replace the rails too. So if you're one of those guys like me that didn't replace those rails, it's a good idea to inspect them at least, because there is orifices inside of these, especially on the Bosches. You're going to see that there's an orifice, and that orifice is a dampener for that pressure inside those rails, and they can actually get dirty or clog. For example, I just got a phone call about 3 months ago, back in January. I got a phone call from a guy where he's saying he was perplexed because he couldn't understand why one side, when he did the power balance, was way weaker than the other side, and the truck had power problems and had a very low boost. Well, in this case, turns out, I said, this might be a long shot, but do me a favor, take that rail off that driver and inspect it. And sure enough, he sent me pictures, and it was clogged. Maybe I should have posted those pictures, but yeah, that was clogged. So it kind of tells you, being since it's a 2002 truck he was working on, that's almost 22 years of debris that's been accumulated in those rails. So always remember, the age of these common rail systems could be a problem. Now, the fuel rail pressure regulator has many names, depending who you talk to, whether it being an FCA, an MPROP from Bosch, or FRPR from Duramax. But this is the guy that has been controlling the rail pressures, which we often call also the volume control valve. Again, many different names for the same thing. But as you can see here, it's a wise idea to understand how these things work, because they are pulse width modulated by the computer on the ground side, so they work on a pull down circuit. But it controls the fuel supply to the plungers themselves to generate the rail pressure. So as you can see here, we see our fuel supply pump to the high pressure plunger. So it's a volume control. But let's not forget, guys, that this is a great tool to inspect how your fuel system is. How clean is it? So from time to time, we take them off of, like on a 5.9 Cummins, we'll take them off and we'll see if they're full of debris or what's going on. But I guess the most important thing, and I'll come back to this guy again, but the most important thing I need you to understand is that all fuel being delivered to the cylinders must go past this fuel pressure regulator. So therefore, as we see fuel going through it, all of it must go past it. So one of the key things we talk about when you diagnose, we've been talking for years, and other instructors have been talking about it too, is look at your duty cycle of your FRPR or your FCA, whatever you want to call it. The magic number was somewhere around 30 percentile. So in this case, you want to be in the 30 percentile region, 32, 34%. And you could look at that percentile when the engine was at operating temperature running, and that would tell you what is the duty cycle of this guy, because if it was too low, then therefore he's having to deliver more fuel, which means you possibly have excessive return. So it was a good preliminary telltale to tell you if this engine was starting to see, or this fuel system was starting to see excessive return. So therefore that you could see it there. We'll come back to that. But the common rail injector from Bosch on these early years and still used by Cummins 6.7 still uses it to the day. So therefore they never went to piezo. So in this case, we see the common rail injector here. But I'm going to give you, I might as well tell you how Tony likes to do it. Let me tell you how Tony likes to do it. First of all, I hope you all know how it operates. Quickly, just a quick recap on this. I don't want to spend a lot of time on this, but fuel rail pressure comes in here. It goes and deadheads against this hollow ball. Yes, I know about the orifices, but in this case, we also send fuel rail pressure to the bottom of this nozzle assembly. Now, at that point, this coil or solenoid is going to be energized, and once that coil is energized with a higher voltage, whether being on the early years 90 volts all the way to 48 volts, it actually will, or its only job is to solely unseat this ball. The ball is unseated, we create a pressure differential. So pressure drops pressure drops because pressure is relieved to the return, as you can see here. So it's a pressure differential game on most common rail systems. And what I mean by that is what moves the nozzle to open and close is actually the dumping of pressure above the nozzle. So therefore, how do we dump it? We go ahead and unseat the ball and it goes to the return. So in the early years, we were having chronic problems. We see it from time to time, especially with crappy reman injectors. That's why I tell people, careful what you buy in today's common rail injectors, because you pay for what you get for, because we don't know how well they're servicing that ball and seat. So therefore, what we're saying is that, you got to watch out for this ball and seat, because we get ball and seat erosion. This is where that lubricity thing we were talking about and contamination can play havoc, because I feel that the weak point of this common rail injector is the ball and seat, which we call ball and seat erosion. So in this case, we're only trying to create a pressure differential where the pressure drops above the nozzle. The pressure below the nozzle is going to push the nozzle up and inject fuel. So that's the way it works. All right. Now, the question begs is that if I have low rail pressure, now we're talking about Duramax and Cummins applications here, so we're covering a lot of territory when I talk about this. And in this case, what I like to do, I'll tell you what Tony likes to do. Tony likes to do what we call an air leak test. And what I mean by that is I like to use nitrogen or shop air, but it's got to be clean shop air, because you don't want to contaminate more of the injector with moist, dirty shop air. Unfortunately, please keep in mind that with shop air or compressed air from your compressors, can only probably reach 150 psi or under that. So therefore, using nitrogen allows me to kick it up to over 400 to 700 psi. And what I'm trying to do is I'm doing a leak test on this ball and seat. And it's worked through the years, and I still do it to the day. And what I mean by that is by using some type of leak down tester, what I do is I have a shutoff valve that I will shut off on my adapter. So therefore, I can literally get on the injector line, and yes, I have the adapters that we made. You can make one from an old line and just put a quick connect fitting with some gauges, but you can use an existing leak down tester, believe it or not, but you need a shutoff valve. And the reason why is because you want to shut off air to see if it holds the air and watch your pressure drop on the gauge. So if you want more details about it, send me an email. But in this case, what I do is a leak down test and watch my rate of decay. So if that ball and seat is leaking and I put shop air in here, then therefore it's going to hold. If it don't hold, then therefore that means I'm dumping it to the return. Y'all follow me? So therefore that works very well to test this ball and seat, but that's all I'm testing, is just to see if am I losing rail pressure to the return system, thus creating a high return because ball and seat erosion. So that's really easy to do. So when you look at a 5.9 or 6.7 Cummins, we've actually changed the test. There's a line going between the injection pump and the rail. And what we do is we literally disconnect that line, and I'll tap into the rail and I'll do a pressure drop test on all 6. So before I have to take off any lines to see if I have excessive return, I actually test the whole rail going to the injector to see if there's leak there. So if it doesn't hold, if it's dropping pressure, then therefore I know, okay, now I got to test each individual injector. Now I know some of you use caps. okay, where you cap off one injector at a time, see if it now holds pressure. Hey, I'm all for it. If you want caps, use the caps. But I tend to like the leak down test because I'm trying to be less intrusive on the common rail system because I don't want to take all the lines off. I'm lazy, but sometimes I have to take them all off. But, try not to. So once again, a leak down test to see if there's ball and seat. Now, you all know about the 5.9 test, right? The snap test. On a 5.9 comes in, it only works on a 5.9 Cummins common rail. Sorry, it only works on those 4 years of trucks. What you do is we do the snap test. And what you do is you snap the throttle, but do it when the engine's warmed up. Snap the throttle, RPM will go up and then come down. It'll take a while for it to go down. In other words, it's a snap throttle test. What should happen is you snap the throttle, RPM should go up and then come immediately down. So in this case, if it takes forever to drop, it takes a steady time to drop, that means you do have ball and seat erosion because it's holding the nozzle open longer, which in turn is fueling longer. That's why. So in this case, that's what you're going to see. Okay. So therefore, that's a snap test you can do at the 5.9. So just snap the throttle and see how fast it drops. If it takes too long, I'm almost 99.9% positive it's ball and seat erosion on those injectors that you're going to see. So there you go. So when we do look at a Cummins 5.9, we all see that there, by the way, there's that line right here, this one right here. This is the one that I like to disconnect. Let me go ahead and put my pointer here. So this is the one we tend to disconnect, and we put our adapter fitting there, and we watch the rate of decay by doing a leak down test, again, either with shop air or nitrogen. But in this case, you see that the injectors themselves, I just did a diesel master course 2 weeks ago. And it was amazing how these guys did not or had issues with these tubes. They were doing a good job, but not lining up. So in this case, almost every diesel master course that I've taught, one of the exercises we always do is installation of the injector. Yes, we have an engine on the stand, and they put the tubes in. And I would say that 90% of them get it wrong. They don't install it right. So I know that for many, they're actually not putting these tubes in correctly and torquing the injector properly. So therefore, we have some leakage there. So when I do a leak down test, they fail. And most likely, it's not the injector sometimes. Yes, it could be injector. Don't misunderstand me, but it's actually the tube itself. So therefore, we got to inspect these tubes to see what's going on. They're not correctly installed. They're cocked a little bit and on, or those injectors are not torqued properly. So therefore, yeah, you want to inspect those tubes. And I guess you all know that when you replace these injectors on both 5.9 and 6.7, you're supposed to replace the tubes. Now, I know a lot of you like to reuse the tubes, and that's okay. But note, though, that tube, the reason why you replace it is because there is a filter in that line. Obviously, you can inspect the end to see it's not actually damaged. But in this case, please note there is a filter in those tubes that many do not pay attention to. But this is an early model 5.9. This is probably an 03 that I'm looking at, because right on the back side here, I don't know if you can see my cursor, but one on the back side, that is the original lip pump they had it. So the lip pump was originally on these trucks on the filter itself. And then with the change in filter styles and so on, they've actually went with the pump in the tank. However, I have run into some trucks where the lip pump is in the actual chassis. In other words, somewhere on the chassis or the frame. So therefore, it can be in one of three places with the years between these 5.9s, depending what model we're talking about. So in this case, yeah, they can vary location. So what is nice about a 5.9, like I told you already, well, the Cascade valve is easy to get to on the injection pump itself. Now, I often get, lessons from shops. I once visited this shop, and this old gentleman was working there. He's great, smart. We got along great. We hit it up great. I actually had too many beers that day. But I asked him, then how in the hell are you testing these common rail injection pumps since you don't want training? He goes, well, Tony, what I just do is he actually got an adapter for this banjo fitting in the back. And he literally, what he does is that he says, well, I just took a banjo fit, I cut it up, and he goes, and I put this to a hose. So he disconnected this. He literally puts a separate banjo fitting here, and he puts it to a glass of water to the hose. I go, okay. And he goes, I disconnect this line right here, and I put shop air through there with my rubber, my rubber tipped air gun. And I just put air through there. If I see bubbles coming out, then I know a ball and seat or a tube's leaking. I'm like, son of a gun. I guess that works. But now we got to figure out which is the one that's leaking. But, he came up with good, because a lot of us are anti-return tests because of the fact that it takes so much time and adapters just to do a return test. And even at that point, you got a cap to see which is going to make a difference in your return flow. It's just too time consuming. So that we're big leak down tester guys. So that's what I teach in those diesel master course that we do. So again, be careful about that. And for those of you that never noticed, let me go back to my 5.9 here. Please note that, for those of you that are not very fluent or new to this, please note that the passage for the return and the tube are all in the same passage. That's why you're wondering, okay, if the tube is leaking, why don't I ever see it? Because it's going into the return. You'll never physically see it there. So food for thought there. So that's what you're going to see. So yeah, there we see our transfer tube going to the side. There's a return hole where the return fuel comes out of this injector. Now, the common rail itself, as you know, is like I mentioned already, it acts as an accumulator. Like I told you, there are orifices, especially on the ends on these early Bosch ones, where you're supposed to check the rail, see if that orifice is dirty or full of crap, because again, that'll affect, but it is there as an accumulator. So please note that that's inside the common rail itself. So as I switch over to the Cummins 6.7, number 10 is the biggie because that tends to be an issue even to the day. I thought we were over it, but now we get them from time to time. Number 10 is actually your pressure limiting valve. You can lose fuel rail pressure right there at the pressure limiting valve. So in this case, I'm going to tell you what I do. I no longer replace them. I cap them. Different aftermarket companies like PPE and other companies, they now sell these caps. In other words, they're just plugs that actually pretty much eliminate the pressure limiting valve. Why is it? Because if the truck sees extensive fuel rail pressure, it'll be detected and he'll derate the truck or shut the truck off completely. So they're just such a pain in the butt because of contamination. They will hang open and they will actually relieve fuel rail pressure during normal idle times or loaded times. So therefore, it's not supposed to pop open so easily. In case you don't know what I'm talking about, these pressure relief valves were initially, so they were somewhere opening around 27,500 to actually relieve excess pressure in case there was a incident where we had no control fuel rail pressure. But like I said already, the system, it's monitoring itself, it could shut it down on its own. Even if there was fuel rail pressure sensor failure, it could still shut itself down. So I'm pretty much a big believer in now that I just go ahead and cap them nowadays. Or in other words, plug them. I just put a plug there because of the issues we've had. And you got to understand, we have some customers just do poor maintenance, even though I'll yell at them and I'll tell them, will you bring that truck in for maintenance, and they can't just let go of the truck because they need it so bad, but that happens. So, but anyways, that's what we see. So one of the things, if you work with Cummins on these Ram and Dodge trucks, is that how many fuel filter part numbers are there? My God, there's so many. And there was a spin-on, there was a cartridge, a top lid, and there's whole different styles of them through the years of all the Ram, both 5.9 and 6.7. So therefore, if you try to stock them all, it was a pain in the butt, So there was always one that we needed, I had to get it. But in this case, yeah, the fuel filters. But one of the things you're going to need to understand is that Cummins was not so great because with the Duramax filter that we saw earlier, that was rated at 4 microns. While these were rated on the early models, were rated at 10 microns. And then they finally started to drop the micron rating, but they were not very good filters on the early years as we compared to the later years that we see. So therefore, if we look at the 6.7, on the Ram Cummins, we saw that they're putting a primary filter now underneath, it's close to the spare tire underneath the truck. So therefore, don't forget, those of you that are new to this, that there is a primary fuel filter now on Ram Cummins since 2013. From time to time, we get customers bring them in saying, hey, I didn't know there was a filter there. Well, I saw the one on the side of the motor, but I didn't know there was one on the bottom next to the spare tire. So please be aware that Ram Cummins has gotten really good about their filtration system. So here you can see the one for the 2013 and later models. Now, we said earlier on the FCA that we wanted to see 30 percentile, like I told you already. And I told you that this unit actually is controlling the volume of fuel going to all the cylinders. So again, it is to your benefit that the Ram Cummins, both 5.9, 6.7, to remove it and inspect to see if you actually have debris. Now, there is no great test pretty much published for these 5.9s and 6.7s for a rolling idle. It is to the point that now I have a spare volume control valve for these applications, because the truck will come in and the idle we call it literally a rolling idle. Our RPM will go up and down and up. It's not a steady idle. That's usually indicative of this is sticking. Now, if the truck's been deleted and it's got an aftermarket tune, that could be an issue too. I've had that happen to me where it was the tuner doing it, not the actual fuel control actuators you can see right here. So please bear in mind that these can actually cause rolling idles, meaning they're starting to stick. So therefore they start to stick. There's nothing you can do with them. I know in some other places they tear them apart and fix them, but most of us, we don't do that, so they can get sticky. But if you do have a rolling idle, I hate to say this, but they're for our parts, for what we get these cheap, you're better off keeping one in your toolbox and put it on just to see if your rolling idle goes away, because there's no good conclusive test with the scan tool that'll help you know if this guy is sticking. So therefore, you could look at duty cycle of it, but I haven't been able to get good concise information from it, unfortunately. So, and remember, like it's showing you here on this slide here, these CP3s, on all these Cummins and all these Duramaxes, remember, this guy is fully open when turned off. So when you disconnect it, let's say the engine's running, you're going to full rail pressure. And that's not a good thing, because if it still has the fuel pressure relief valve on, whether it be in Duramax or Cummins applications, you're going to send the rail pressure. Possibly, if you get above idle, you can pop that pressure relief valve, and you don't want to do that. So therefore, if you are disconnecting, what you want to do is you want to actually do it only at idle and don't hit that pedal. Okay, don't hit that pedal at all. Now, sidebar. These injectors on these 5.9s, I haven't seen it on the 6.7, but 5.9s, we have seen it, and it's still, I get a phone call occasionally about this once in a while, was that these injectors, depending who rebuilt it, again, those crappy rebuilt injectors we had literally an injector leaking into the crankcase. So therefore, you pull the dipstick out, you were 1 quart, 2 quart over, right? The thing is, some of them were not that easy to find. So what we used to do, or we still do, is we go ahead and disconnect the FCA, this guy right here, we disconnect them. We take the valve cover off, obviously, and we want to see the 6 injectors right there on this Cummins application. And what we do is we crank the engine over. Now, you could disconnect the injector harness connectors right there next to the valve cover, so the engine won't start. And what we're doing is, with this guy disconnected, like I told you, we're going to full rail pressure. So what I'm trying to do is find that leaky injector with 20-some thousand PSI of pressure to the injectors. So literally what I'd be doing is I'd be looking, I'd be having somebody crank the engine over for me, and I could see which injector was possibly leaking. To be honest with you, I like to use a colored LED light, like a green one or blue. And what you can do is you can try to find that fine mist spray coming off the top of that injector, usually around the solenoid or that actual pinhole that it's got there. So therefore, you're trying to find the leak. So this is a great way to find a leaky injector on these 5.9 Cummins. You could have done it on some of the LB7s, LLYs, because some of them did that too. So therefore that worked. If you get a situation where you're getting dilution of the oil on these model trucks. So now the fuel rail pressure sensor is a critical sensor on these Bosch application, has been proven to be very well. But I'll be honest with you, on 6.4 Power Strokes, they have given me issues. If you've seen my diesel talk on Tony Salas YouTube, I do have where I'm showing one on a 6.4. Yeah, they're not very good. So therefore, we keep a spare one for a 6.4 too as well, because they have been known to be biased, meaning that the voltage hangs in a certain threshold. So, but I got to be honest with you, on these Bosch applications, that has not been the case though. And as we look at the Denso L5P that we talked about a few months ago, you found out that that pressure sensor is also iffy too as well. So it's been a problem. But note that that rail pressure sensor is very critical. But do me a favor on the 5.9, 6.7s, well, all of them really. When you're looking at rail pressure, and I'll show a graph real quick here in a bit, but when you're looking at rail pressure, do me a favor, look at desired, look at actual rail pressure, but also look at the fuel rail pressure signal voltage. Make sure that signal voltage is not biased, not sticking at a threshold, because it could actually cause issues. Now, we have seen crazy things happen very rarely on these, but just note that this fuel pressure sensor has a range between 0.5 to 4.5 volts. So if in doubt, you can actually back probe this sensor with a meter or scope, and you can watch actually the analog voltage signal go up and down. In other words, from 0.5 to around no more than 4.5 under full load, and see what that voltage is. Because if that voltage is skewed all of a sudden, that means that you got an issue going with the peroxide, which can cause an alpha idle acceleration. Hell, it can cause cylinders not to work, believe it or not. So it could cause a array of different stuff. So, and this is directly from the book from RAM. It says, or like it says on the bottom of the slide, if the rail pressure sensor fails, the ECM substitutes a default pressure value. And the only way you know you got that default value is looking at that signal voltage off the sensor. So always look at that on those applications. That's why here's an early, I found this old slide. And in this case, the reason why is because it was on 08. And in this case, you can see the fuel rail pressure sensor reading. You could see also the signal voltage right there. So always look at that signal voltage, see what it's going on with it too as well. Now, I also like to show what's available. I mean, you guys got a lot of toys to play with when it comes to, what do I got to use? For example, my Snap-on tools here, and no, I'm not advertising for Snap-on, but it's a tool that I use. And in this case, there is features where it tells me how to test that fuel control actuator, the FCA that we just locked, also known as the MPROP as well, like I said already. And in this case, it tells me how it's actually routed, shows me the pin connector. And also pin 1 is the on and off signal grounding. And then pin 2 is your 12-volt supply. So I should see battery voltage going to it. So it tells me how to do the test there as well and how to do it properly. And it also sets up the meter. So like I've been using this tool for years. This is my Veras. Now I have the Zeus. I'm spoiled rotten with it. But in this case, it makes it easy for me to test voltages, what's going on with it. So guys, I understand some of these Duramaxes and some of these Cummins are getting old, so it's a wise idea to inspect those pigtails, see how they look. So because they can be beaten up through the years, they're fried, the connectors, lock connectors. No zip ties. So therefore, replace those pigtails as necessary. Now, when it comes to diagnostic trouble codes, yes, there's many different codes. Like for example, here's off of a 5967. There are codes for fuel pressure sensor high, sensor low. That means that's not rail pressure, guys. That's actually circuit. So therefore, when you look at codes, understand what the code is telling you. And I get frustrated when guys call me or I see situations, guys posting their headaches, and they're not reading the code itself. Sensor high means what? It's on the high side of the circuit or the low side of the circuit, whether it being ground or whether it being the positive potential. Understand that's electrically speaking. So one thing is electrically speaking of the component, and the other is the pressure, and that's what we see next. Fuel rail pressure too low or fuel rail pressure too high. But then you could have circuit performance, meaning that maybe there is too much cycling of this pressure, so he cannot differentiate whether it's a fuel rail pressure problem or an electrical circuit problem. Regardless, though, your job is to inspect all the different aspects of the sensor or the system itself. So there's got to be some structure how you're going to approach this. But in this case, just note what the codes are telling you. Not to mention you can get a field delivery error, but usually that's accompanied by another code that's telling you more specifically what's going on. But don't forget, as you look, for example, on this old 5.9 common rail, don't forget that there is pressure relief here. So like we just mentioned on the 6.7, there's the one for the 5.9. Yes, the Duramax has them too as well. So therefore, the pressure relief valve can be something that's leaking. And by the way, when you inspect these like this old 5.9, you take the banjo fitting off right there where that white line is pointing to. Please note, when you do a cranking test, you want to see if it leaks, there should be nothing, no moisture, nothing of anything of fuel there. If there is small moisture, that means that thing is leaking and it has to be replaced. Or like I told you already, I like to plug them. So therefore, that's something that you want to do. So again, nothing should be there. And here's the one like we showed you off of number 10 on the 6.7 of the pressure limiting valve. A quick side note here. The quick side note here is the water and fuel sensor. Please note the water and fuel sensor is a critical player because, again, it does tell us what's going on. It also is accompanied by the fuel heater on some of these models, so please note about that too as well. But the water and fuel sensor, take heed to it because, again, that can actually give you a more indicative what's going on. And by the way, if you do have water and fuel indication, don't just drain it. The question begs is if there was a substantial amount of water in the filter that was collected, how much is in the tank? So you may want to keep an eye on it, or it might just justify the fact that I may have to pull the tank down to see what is the water content going on. So here you can see a Cummins 6.7, how many codes are set for the whiff sensor. So yeah, it's showing you right there, the water and fuel sensor circuit high, circuit low. So I guess it's now scrutinized on many applications now where you're going to have codes that relate to the actual water and fuel sensor. So therefore, keep an eye on that. And yes, once again, I know you're going to drain, like I just said, but again, you want to make sure you actually keep in mind it, how much water is in that tank. So we don't know. So as we're finishing up here with the CP3 and we're moving on, again, there's your Cascade valve, there's your FCA, and there's that transfer pump we were talking about. Now, for those of you that don't know, I have been known from time to time because the 5.9, I've done it on a lot of 5.9 Ram Cummins trucks, not so much on 6.7s, but there have been some customers that I'm like, you know what, we were in the, there's a long story, but what I had to do literally is I actually put a Duramax style primer pump system on it, and I actually got rid of the pump in the tank, and we literally made it a Duramax on the Cummins, meaning that it was sucking the fuel because Ram Cummins has that same transfer pump, so technically it didn't need the lift pump on those applications, so he can pull the fuel from the tank on a 5.9. So I have done that. So I got actually a few of my customers are still running that way. So therefore it works, no lift pump there. But please note, some of these 5.9s and 6.7 can trigger a code if that lift pump is removed or disconnected. So you're gonna have to get creative with resistors. So be aware of that. So that's enough of that. And then we talked about the M prop. What did I tell you the duty cycle was? Somewhere in the 30 percentile. Remember that. So therefore, please note, for diagnostic purposes, the ECM itself on these applications is also monitoring the fuel pump current too as well. So therefore, pretty cool. And there you can see the later model 6.7 Cascade valve, easy to get to. Hey, you can tell this is a Las Vegas truck. You know how you can tell? Because look at all the sand around it. This is our thing here. The wind blows up the sand. So therefore, this is definitely a desert truck, as you can see there. So, all right. So we talked about the Cascade valve. And here you can see a chart that Bosch put out years ago. And what you're going to find here is, here's your some spec you can work with. There's your high pressure pump return flow test. This will tell you if the Cascade valve is leaking. So you're literally going to do a return test coming off the pump itself. So therefore, again, the allowable return according to Bosch is, again, 1,000 milliliters per second. So therefore, I mean per minute. So in this case, that equates to what? 1 liter. So if you exceed 1 liter in 1 minute, so there, that means you got a leaky Cascade valve. So there you go. That's how you test a Cascade valve on those applications. So we said earlier on those Duramaxes from LB7 to LML, we can prime the pump, see 10 PSI, watch the rate decay, but on a Cummins application, we can actually measure the return flow. And I'll be honest, that's about the only return test I do on these Cummins applications, because like I told you, I do the leak down test as well. All right, moving ahead. We see the IQA codes. Please note that the IQA codes are actually important. Got to program them in. You may have gotten away that, hey, it doesn't trigger a code, but remember, this is a fine tuning device. So I know that I know that Cummins 6.7 got rid of them after 2012, 2013. They got rid of IQA codes. So therefore, there's no programming in the injector. The computer can actually adjust the fuel trimming on this. But even on the new L5Ps, we still have those Denso common rails that you have to program those IQAs. So do me a favor, program those IQA codes. Now on the Duramax application, let's say an 06 LML, no, excuse me, LLY, LMMs, LBZs. Those actually, a backup copy of the IQA codes goes into the glow plug control module. The popular phone call I get about that is, hey, Tony, I'm able to program the IQA codes, but it gives me an error code. It won't transfer over to the glow plug control module, because those of you who don't know or never done this, yes, you program the IQA codes to the ECM. Then the ECM, you transfer it over with the scan tool. You transfer that file over to the glow plug control module. So it's a backup copy. But if they don't sync, they don't want to sync the IQA codes on both the glow plug control module and the ECM. The way I've been able to fix it is I had to reflash completely the glow plug control module along with the ECM. So something to keep in mind when you're dealing with those models. Okay. All righty, moving along. A lot of common rail stuff here to talk about. All right, the LML Duramax. As you can see, the LML Duramax, holy cow, man, look at this stuff going on. Number 14, it was the introduction of the indirect injector, which we call the hydrocarbon injector, or some of you call it the ninth injector. In this case, but the sucky part about this is that it was using return fuel off of the injection pump, as you can see coming off of number 14 and number 17. So in this case, we see that we got a high return, we have a return coming out of the injection pump that supplies the fuel. But unfortunately, crankcase fuel tends to be dirty, so we see these injectors from time to time get clogged. Therefore, it won't run a decent regeneration. So in this case, please keep in mind, A, do a good job of putting that banjo bolt, because we've had quite a few trucks come in, whether being with the CP4 or with a retrofitted CP3, they don't tighten that or they don't change the banjo gasket, so it comes in with a fuel leak. So for me to get that pump out again is mega labor. So in this case, please keep in mind that when you are putting that banjo bolt back on, or that fitting back in, that you actually seal it correctly, because you don't want to go back in it, because you'll wind up with a leak. So please be aware of that, because we gotten a few of those, and even the shops next to me have gotten them too, and they're not happy because they've had to go ahead and had to reseal it, and that's a lot of labor. Now, again, Duramax, once again, is sucking the fuel, but my question here is, you're going to see you got a transfer pump. So please note this transfer pump goes from primary to secondary for those with factory filled trucks. So we're going to see that there. So, but in this sense, we use a piezo common rail injector. But like I told you already, if this is an LML, again, if I see catastrophic failure, or I want to upgrade this guy's or customer's fuel system, I will put a aftermarket lift pump in it, and that works out very well. Remember though, like we were talking about earlier, these injection pumps are timed, so therefore make sure you time them, these CP4s. So therefore, these systems are now capable of hitting 29,000 PSI. So we talked about the CP4s in the past, so those of you that attended my training, but in this case, please note that the VCV is one of the places where you can remove to inspect to see if there's contamination. Some of you have put contamination kits in them, that's fine with me, but just note that, you got to understand that fuel lift pump pressure and volume are the key, which I'll go over here in a second as I get also into the common rail piezo for a 6.7 power stroke. Now, the power strokes have now come up with new stuff. You've heard me talk about it in the roundtable. The biggest issue we're having right now, well, somewhat of an issue, especially those trucks that do a lot of idle time or low speed, a lot of hours, in other words. Those are the ones that we're starting to see major erosion of the injector nozzles, but also we're starting to see them break down internally, which in turn will send compression gases into the common rail system. So it's pressurizing literally the common rail system. So we have to know the system, how it basically works. Obviously, we have same components like we saw before, from the early to the later model Power Stroke 6.7s. Number one being our fuel pressure sensor. We see the fuel lines, which are not reusable. We're seeing the injection pump, which originally came with the CP4. And in this case, those are the injectors themselves that we see there. But then up there on the upper right, we're going to see the pressure relief valve. Nope, it's not a pressure relief valve, but it works like a pressure relief valve. It's called a pressure control valve right there. So like we saw in other common rails, we saw a volume control valve and a pressure control valve on the rail. One control low pressure volume of fuel, the other one controls excess pressure. So therefore it's on the high pressure side, as you can see there on the upper right, on the back side of the rail on that driver's side. But in order to understand, we have to see the returns here. So the returns from piezo, because return pressure is needed for the piezo injector to work. So therefore, you're going to see, like we see on these early models, that the pressure return coming from the injectors also was the same as your lift pump pressure, which was somewhere in the vicinity of 55 to 59 psi. So we saw again that here's your inlet line of the filter, and in this case we saw that that return is going right back. So it's circling itself from the return from the lift pump pressure itself coming in. So therefore you want to do that. But a sidebar here on this, please note that I still believe in volume, whether it being on an L5P, whether it being on a Power Stroke 6.7, I still believe what Cummins says, and that is volume test. And I still use that, roundabout number of 1 liter in 30 seconds. It's a good idea, yes. If you do suspect there is some type of pickup problem in the tank or something's wrong in the filters or in the lines, you could still do a volume test. So at the shop, I have a long hose that actually connects to the outlet of this filter, and I could literally go ahead and measure the volume. And yeah, I want to see that full 1 liter in 30 seconds. So therefore, definitely want to do that. So let's, even though we can read the pressures, or maybe depending on the system you got, or you have a low pressure switch there, like these Power Stroke 6.7s have, it's still a good idea to always do a volume test of, again, I like to use the roundabout number of 1 liter in 30 seconds. So if I get very low volume, that could mean that I got a restriction somewhere, or I might have a pump problem too as well. So as we look at your later models, you're going to see that the fuel filter itself now has 3 tubes sticking out of it on the 6.7, because one of them is actually the return off the injector. So they modified it and changed it on these applications. So therefore, that return is also going back. So the question begs is that if I get the system coming in and I got a rail pressure problem, like we mentioned at the beginning of this presentation, is the number one thing you got to always figure out, is this system grenaded or is it contaminated? Because many of us will find that they're contaminated, but they could also have some contamination, but yet still work. So I'm advocating, I've always done this on these Power Stroke 6.7, is I like to get to the pressure control, which they call the FRPR on the Duramax, but on the Ford, it's your pressure control valve right there on the back side of that driver's side rail. So yeah, I'll take the inner fender well, I'll take that off, and I will go ahead and put it in the container and crank the engine over and see what it spits out. Because what I'm trying to see is if there is metal contamination there. Definitely want to do that. Now, I know that Ford software, as you can see right here, I know that Ford software actually allows you, oops, let me mute this. I'm trying to mute this. And I know that there is, oh, for Christ's sake, do me a favor. There we go. So therefore, what I'm trying to show here, I'm trying to take the sound off, is that I know that the Ford software, if you don't have an IDS, this is what you're missing out on, Ford IDS scan tool. But in this case, you're going to see the desired and actual rail pressure here. And in this case, we see the desired, but I like to pay attention to the duty cycles of the PCV, pressure control valve, of the volume control valve. I see the duty cycles because those two work at all times together for the most part, unless it's on a decel. But in this case, you'll see it, what we call the ramp up test. And what it does, it ramps up the pressure. So here you can see the first ramp up test. And then what it does is that it ramps it up again several times, as you can see here. So watch it here for a second. Let's see, desired 4,900 is going to ramp it up. Bang, it takes it up to 29,000. We see if we achieve 29,000. The one thing I don't like about this and other applications is the fact that it doesn't not simulate real life engine load, because this truck is under no load. It's sitting there in park or neutral. So therefore it doesn't. So you still should watch your desired and actual or commanded and measured rail pressure when you're driving under a load to see what's going on with them. Now, what I like about this test, though, at the end, as you're going to see, it's going to do a few more ramp ups. And what's going to happen is, at the end of this test, it's actually going to shut off the engine, but it's going to hold the pressure to see if there's leakage. That means it's going to test the integrity of the injection system, but also the pressure control valve and the volume control valve. And that's what you're doing here. So make a note, it is a good test when it comes to also checking for rate of decay or leakage that can happen when you shut off the truck. So therefore, let me wait for it here. You're going to see the results and see what's going on. And by the way, you'll notice my engine coolant temperature is above 185. Always do these tests if you can above 180, 185 at operating temperature. So here you can see it's holding the pressure. See that? So it's watching for rate of decay. And then it'll tell you if it passed or failed. So therefore, there's your pass. There's your minimums and maximum, and there it tells you if it passed or failed there. So that's one good thing about these Power Stroke 6.7. You should perform using their software there. Unfortunately, when I connect my Snap-on Zoo scan tool and other scan tools, they do not give you this. But if your scan tool does this, great. But in this case, it's a good idea to test especially for leakage from that PCV and VCV, like I said already. Now, this should be an old thing, but I have heard guys call me up where there was a problem with the rail. So I guess me putting this out there in previous, like I did in previous presentations, is always look for bulletins. What's going on with bulletins on these common rail systems. So in this case, this is an old one for the 6.7 Power Strokes, where the internals of that orifice, or diverters they like to call it, can actually come apart. And another reason why I also like to take that pressure control valve off, because I'm also inspecting for damage. So again, not only damage, but I'm also inspecting for contamination as well. So please note there was a bulletin on that as well, and it was telling you what part numbers that was bad. A lot of you know this already, some of you don't, but just note it's a good thing to take those off and inspect them. Now, I know that if you're dealing with a Powerstroke 6.7, and we talked about in the drivability roundtable already about the standardized pump that is now marketed by S&S. Like I said, you may be prone to want to put a aftermarket or a CP3, some type of pump in there. Just understand that these CP4s, they are, again, designed to work with the high pressure that they're designed to work with. So first of all, I've talked to a lot of different shops and people, and I get mixed results. And so some people saying, yeah, Tony, we're seeing less CP4 failure, while some people say, hey, we still see the steady amount of failure. The one thing I could tell you, once again, repeating like I did in the roundtable, was, the weakness of the CP4 is low lift pump pressure and volume. But if you remember earlier, if we have compression leaking into what and it's causing the drivability problem, because you got to understand, some of these fleet trucks that we get, these guys will keep driving, even though it's sputtering along, they'll still drive them until they put them into the ground, these poor trucks. So therefore, if there is compression leaking, it's going to aerate the system, because one of the weaknesses of these CP4 pumps is air. We don't want to see air, and it can destroy the CP4 pump. So therefore, please note, the number one thing we tell guys from a service standpoint is when you change the fuel filters when you change the CP4 pump. God dang, I'm saying this wrong. One more time. When you change the fuel filters on a Powerstroke 6.7 or a Duramax for that matter, it's a good idea to let it idle for at least 15 minutes after you're done, because you want to let it work all the air out of it. So therefore, that'll minimize or lower the amount of air that can hurt the CP4 pump. And I got to tell you, and I'll say this again, for the trucks that I got, I just serviced one of my fleet customers right now. He's got 168,000 miles and he still has the same CP4. It's a 2011 truck. No issues. But again, I tend to follow those procedures. So have we seen a whole bunch of CP4 failures lately? Nope. I haven't seen a whole bunch lately. So just keep that in mind. And remember, for those of you that still insist on using the CP3, go ahead, whatever you want to do. But remember, the CP3 strokes 3 different times for 1 revolution. Like I've said before, there is a cam that strokes twice each of these cam lobes. So therefore, it strokes 4 times for revolution versus the 3 times of the CP3. So if there is a real pressure, we tend to do some cheating things. But again, for being professional about this, I could tell you my Mickey Mouse ways, but I don't want to teach bad habits. But in this case, your best friend is probably the cap. Okay, the caps. And the reason why you want to do a cap test, but note that every time you do a cap test, you're going to have to buy a set of lines, because the fact that once you remove these lines, according to Ford, you're not supposed to reuse them. But in this case, it's just going to cost money to do that diagnosis. So therefore, you want a cap. The line going between the one rail to the other, one rail feeds the other, that's the one where you can isolate a whole group. But again, you're actually going to cause integrity issues with the line. So therefore, capping off one at a time is probably your best bet. So those of you that are new to this, I can tell you cheat ways, but that's off the record later. So there is that pressure control valve that I was showing you. So is there a volume test you can test off of it? Yes, there is a volume test you can do. So you can disconnect this and cap it off, and you can actually test to see the total volume coming out of it under a cranking event. So there is specifications that they provide for you. So just keep a note of that there. So therefore, you definitely can look at that. So. All right, to stick to the basics here on that common rail, obviously there's more in-depth stuff to talk about, but that's the stuff we got to get over with when we're dealing with common rail. But like I showed you already, here you can see an example of a graphing that we actually have. So here you can see the fuel rail pressure, the set point, the desired, in other words, of the rail pressure, and then what is the actual percentage of duty cycle that you're going to see there. So on the average, you can see when it was stable, here you can see the pressure here stable and stable, you can see we were running around the 30 percentile, like I told you already. So therefore, it does work. So therefore, definitely want to pay attention to that when you test. And you could see it also on your scan tool data as well. All right, last one. Yes, there's so many commoners, I'm going to talk about so many here. But the last one here with the time I got here, we're moving right along, is the L5P. We did talk about L5P, reference the last L5P, like I told you already that we did for Lucas here. But in this case, note that, you got return system here, you got your lines right there. So therefore, again, we have to be careful with these L5Ps. As you know, we covered already the operation of it. Unlike the LML, the L5P and the L5D all are using a Denso common rail system. So what have been the issues that we've seen? Well, the number one issues we've seen is number 4 injector. Some people are telling me number 5, but we've seen number 4, map sensor. You see probably the carbon. Now they're selling a spacer now you can put on the map sensor. And obviously the big one, which is the fuel rail pressure sensor. And then that doesn't even cover the lift pump along with the actual fuel pump driver control module. So that's another one there. So if you haven't learned L5P, definitely watch that video that we did with Lucas there off their YouTube channel. But in this case, please note, you got to understand that number 7 is probably the big one. If you haven't yet had training on the L5P, the one thing I will tell you is that number 7. That number 7 is the fuel rail pressure sensor. But this guy's different than previous models we worked on because it is a 2-in-1 sensor. So it's got total 4 wires going to it because it's a 2-in-1. So therefore, GM has had bulletins on it. There's many videos about talking about this. So your job now is to inspect it when you got fuel rail pressure issues, surging, acceleration, and so on. So therefore, you have to inspect. It's no fun to get to either. It's right there on the front, buried there on the passenger side. So therefore, you got to inspect it. The telltale usually to tell you if that sensor's been serviced or the pigtail's been done is that it'll be full of dielectric grease. So therefore, and if you haven't done it, they're going to tell you to put dielectric grease in there to pack it in because they're having issues. If we compare that to the Duramax LM2s, you'll notice that GM has a lot of issues now with pigtail connectors, whether being on the fuel rail pressure sensor, whether being on the pump, or whether being also on the injectors. Yeah, pigtails are becoming a problem. And if you know your Duramax from back in the day, we did have pigtail problems back with the LLYs and the LMMs and the LBZs. So in this case, yeah, we are seeing issues here with that. So for the record, just know your L5P fuel rail system because it is going to be a challenge. So we do discuss also about fuel timing and fuel quantity codes. I'm not going to get into that because I already covered that in the Lucas L5P. We did a 2-parter there, so watch for those videos, like I said already, on the Lucas YouTube page. So therefore, know the system, how it works. Just note that there is a lift pump. It is now a 3-phase pump. So this is the first from the big 3 that is using the 3-phase pump. That means this pump, we're monitoring its fuel speed, we're monitoring its output and pressure, because we can read with a pressure sensor they put on the low pressure side, we can read lift pump pressure. So in this case, that allows us to do that. So again, you got to know the system because this one is pretty much the one that stands out different from the rest of the common rail systems for the simple fact that, again, that has a 3-phase pump. It's got a fuel pump driver module. You can regulate the speed, and there's 3 wires that control those phases, 3 phases along with the ground. So in this case, it's cycling, averaging around 6 volts each pin. But again, there are diagnoses that GM does provide and codes that helps you with it. But it's given us a little bit of a headache, especially on those trucks that have been deleted, So therefore, those are the nightmare ones that I've dealt with too. So therefore, be aware of that. So definitely get up to speed on those L5Ps because those are the ones that are going to give you a headache. But like I said already, look out for these other issues that can be causing fuel injector quantity, fuel injector timing codes, because again, they can be a nightmare there. So hopefully that helps. And the next thing I guess I got to finish up with is do me a favor. If you're not fluent in electrical and wiring diagrams, yeah, you might think this is a sales pitch, but it's not. It's the sincere truth. When guys want to do back probing, when they want to do, again, testing, they're just on the phone. They're driving me crazy. And those guys that I deal with here, this group that I'm trying to train right now here in Vegas, oh my God. And even the feedback I get from the guys in the Diesel Master course, holy crap, we got a lot of issues there. So get to know this. And here, what I'm just trying to show, like I've shown before, is you got to have a signal coming from the ECM to enable that lift pump, which is at pin 18, cavity 18, and then there's your 3 phases going to the pump itself. But again, that's a whole different subject that I can't cover today, but we have recorded that, so we do talk about it. So therefore, pay attention to that. So I guess what I'm trying to say, and again, it's not a sales pitch for training, but it's a truth, is you got to get up to date on these wiring diagrams and electrical train, how to do that test. So therefore, pay attention to that. And I guess I'll just throw the sales pitch real quick as I'm finishing up here is, guys, if you don't know your common rail systems, and, this is why I wish everybody would attend the Diesel Master course, because this group of guys that I just had, small group, but great guys, hard workers there. They helped me out with a job actually. Is the fact that they didn't know a lot of this stuff, and they came out smart. They felt good about it. The feedback we got from them was good. But again, if you don't know this stuff, you got to get up to date. So if you got training, you got to get the training in there. So come on, you're only going to learn so much here in an hour and 20 minutes or so here that we're here. So with that, David, I put you back on. Mr. David, are you there?
Yep, I'm here. I just had to find where my my mouse was, my pointer there to unmute and so everybody can see me. Tony, once again, wow, a lot of really, 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 really good information. Even though for me, for example, I don't necessarily work on the vehicles, but wow, it's super interesting, and all the pointers that you give are wow. Okay, really, really appreciate that.
Thank you, sir. Thank you. Thank you.
Let me just do one thing. I'd like to share my screen here just for a moment. Let me see. And okay. There were several questions. Actually, we do have quite a few questions. One of them is, and the reason for sharing my screen here while you were talking and you were giving all of this great information, there were some questions that I tried to work on, a little bit of information to show you here and share with you. But one of the questions says, does Lucas offer, what does Lucas offer in the way of repairs for common rail systems? And I'm really glad somebody asked that question, because frankly, we offer a lot of not only information, we offer training. Let me just get here. We offer training. We offer all the individual components for repairing and remanning all of the injectors. And we also offer all of the parts for the common rail pump. So in other words, as you can see here from the diagram on the left, we have the bodies, we have the nozzles, we have the seals, the O-rings, springs, you name it. We have all of these components for all the major brands of common rail injectors out there in the marketplace. And as I said just a few minutes ago, we also offer all the common rail pump parts for you for all the major brands. So not only do we offer the parts, but we offer the training in order for you to be able to use all of these parts correctly and to assemble the components into one unit. And then in addition to that, we also offer the test equipment. So in other words, we offer the complete package of training, parts, and the test equipment. As you can see here on the right-hand side, we have a very small piece of test equipment for testing one injector at a time. But we also offer a complete range of test equipment for measuring, for testing the injectors, testing the common rail pumps. And here you can see on the left-hand side, we offer test equipment for testing at least 4 injectors at a time. So in other words, that will cut down on your test time. So we offer single, multi-injector machines, multi-brand as well. In other words, they'll do all the different brands, whether it's the Bosches or the Densos or the Delphis. And we offer multiple settings, for you to offer the maximum performance of the injector. We'll test electromagnetic injectors as well as the piezo injectors. So long story short, we offer test equipment for the entire range of all the common rail systems that are out there at the present time in the marketplace. And speaking of this, we offer the equipment to basically conform to just about everybody's budget. And speaking of budgets, for this special webinar that Tony just gave, we're offering a 5% discount in addition to your normal discount on test equipment. So this discount is good until the end of the month. So by the end of March, that offer will be over. But here are our contact information for Erica Ricardo, who works in our Detroit office, and for myself, I work in the Kansas City office. If you contact either one of us, we will be able to help you out and give you a lot more information on tooling and everything that's necessary in order to be able to test common rail systems. Okay, going on to one other question that there was out there. Let me just stop sharing my screen so I can get into, oh no, I can get into Q&A here. Okay. Okay, one of the other questions, Tony, this was more for you to answer. You were talking earlier on about the fuel cap on the various different applications. And the question here is, does this throw a code? In other words, if you have a cap that the valve is not working properly or the little relief valves are not working properly, does this throw a code, or is it something we should be checking, on a frequent basis when the vehicle is in the shop?
If I think you're asking is the return?
No, the
If there
fuel
is,
cap. In other words, the cap on the fuel tank cap.
oh no, it won't set a code. But it will affect your fuel rail pressure. So I guess it would be fair to say it'll probably set a 0087 code because it's having a hard time getting fuel up to the injection pump. So the answer would be yes, it could set a low rail pressure code because it's not being able to pull fuel adequately, especially under a load. So it'll be setting a low rail pressure code.
Okay. So similar to, I know we're only talking diesel and we're talking, pickup truck market, but on gasoline jobs, if you have a cap that you didn't put on properly, once you fill the tank up, after a short period of time, it will throw a code that says, check engine, your check engine light will come on. So I guess
But the
here,
most important thing to keep in mind about that is not so much a code, is the fact that it's collapsing the tank. So in the past, even
yeah,
from the past days of 6.5, we used to have collapsing tanks because of the suction creating such a low pressure.
sure.
So I guess I didn't mention is that we should be inspecting these fuel tanks. So
Okay.
see if they're not actually leaking at the seams, as we say. So
Okay, very good. The second question had here, it says something to the effect of, when you idle the engine, just towards the end of your presentation here, it said when you idle you've got to idle the engine in order to remove the air, and you recommended about 15 minutes. Why can't you run it at a higher speed? In other words, press the pedal and run it at a higher speed in order to reduce that amount of time, the 15 minutes or so that you're trying to remove the air. Is there a reason for idle only?
first of all, let's get one thing clear. That actually did not come from me. That came from Ford back in 2011. There's an old bulletin that I have to fish out that we got that from. And
Okay.
then we discussed it in numerous meetings with not just me at the roundtable, but me with other corporate people. And the thing is, we came up with it because we're trying to work out any air. By going to a low idle, we're trying to promote less air, at a time going through the pump as it's working it out. So by going to a high RPM, we could actually in turn cause more pressurization in the crankcase of that CP4 pump. So the answer is we're trying not to put so much air, if there is air, into that CP4 too fast. So that's why we stay idle speeds.
Okay, very good point. Appreciate the clarification there. I'd like to give a shout out there to Tony's class, his master course. I was out in Vegas last week for a big show called ConExpo, all the construction and equipment show there. And I was at Tony's class there for a short while. And one of the benefits that I see is with a course like Tony's, you're really learning what we call real world issues, meaning to say that all of us have been to many different classes throughout our careers. And you go to some classes and the classes are purely theory taught by maybe someone who really doesn't get out in the field at all or very much. And in turn, it's not real world. And as you can see and hear from Tony's presentation today and all the previous ones, what Tony teaches is real world problems. And there was another comment in here about the fact of all these little tips. You can go to a class, not necessarily Tony's class, but, a theoretical class, and you don't get all these real world tips, such as the one that Tony talked about, the common rail itself. Most people would think, the rail is on there, it's just a piece of tubing, it's empty inside, it's never going to go wrong. And as Tony described, yeah, there could be quite a few issues with regards to the rail itself. So going back to promoting Tony's master course, it was very, very good for the amount of time that I was there. And it's real world versus just purely theory. So I'd recommend his class to anyone who's in need of some training. And that's basically all the questions that we have today. I want to thank you very much, everyone, for participating in these classes. As I say, this is going to be on a weekly basis. And we have, let me see, one more. Okay, one more question, and then we'll wind things up. It says, Tony, is there really a difference between fuel injection pump CP4 F Series Super Duty 2020 to the 23 and years before?
And the answer is yes. So there are differences in there. There's a CP3 or CP4.2, and there were previous versions of it. So the answer is yes. So when you buy one, you're getting the latest model if you are getting it from Ford, but other suppliers, you would have to ask them. So, but you should be getting the latest updates to the CP4 pump when you get a CP4 pump. So.
Very good. Okay, once again, thank you very much, Tony. We'll see you again next month with a whole new topic. And very much, as I said earlier on, very much appreciate all the really good tips that you give us and share with us in the real world that's out there. So once again, see you next month, everyone. And hope everything goes well for you. Thank you. Take care, everybody.
I'll take care.